The sum of the first n terms of an arithmetic sequence is given by Sn equals to Pn squared minus Qn, where P and Q are positive constants. It is given that S4 equals to 40 and S5 equals to 65. Find the value of P and the value of Q, and find the value of U5. So for A, we have to find the value of P and Q, and we can see that here Sn equals to Pn squared minus Qn. So that means that S4 would be able to substitute n right here with 4. So S4 would be P4 squared minus Q4, and expanding this even more. Oh yeah, it's equals to 40. It would be 16P minus 4Q equals to 40. And for S5, we can do practically the same thing, where it would be P5 squared minus Q5 equals to 65. Sorry. And then it would be 25P minus 5Q equals to 65. Now, we can either solve this, which, as you can see, is a simultaneous equation. We can solve this through elimination or substitution, but since I like to make everything harder for myself, I like to use substitution. So let's take this equation right here and just move p to the other side. So it would be minus 4q equals to 40 minus 16p. Then it would be q, and I'll just leave the negative on the outside. And 40 minus 16p. So you can see there's a negative there. And we basically can see that it would be 40 divided by 4, which is 10. And then 16 divided by 4, which is 4p. This would be minus 10 plus 4p. Then we can use this right here and substitute it into the q right over there. So here we have 25p minus 5 minus 10 plus 4p equals 65. Then it would be 25p minus plus 50 minus 20p equals 65. And here would be 5p equals to 15, and therefore p equals 3, because 15 divided by 5 is 3. Then we can substitute the 3 into this equation right here. Any equation really, but this equation I'd like to use. So it would be 16, 3 minus 4q equals to 40. So 16 times 3, 48. Would be 48 minus 4q equals to 40. And then we move 48 to the other side. Minus 4q equals to minus 8. And therefore q is equals to 2. So now that we found that p and q is here. So p is 3 and q is 2. So final value of u5. There are a few ways to find this. You can use like the arithmetic formula, the arithmetic sequence formula, which is this right here. But I'd rather use these two values to find out u5. So if we break it down, what is S4, right? So S4 is 40, and S5 is 65. So what exactly is S4? Well, it is the sum in an arithmetic sequence up to the fourth index, right? So it would be U1 plus U2 plus U3 plus U4. Now, what about S5? Now, S5 would practically also just be this, right? but it would include plus u5. So what happens if you different if you take s4 out of s5? So it would be s5 minus s4. Now this would be all of this right here, all of this minus all of this. So that would be leaving this, leaving this, this, and this, which would leave us with u5. So s5 minus s4, 65 minus 40 is equals to 25, which is our fifth term in this arithmetic sequence.